Hi class, I'm Matthew. I'm a freelance translator and also a part-time tertiary education instructor. The topic we are covering today is Introduction to Translation Technology and the current development of technology for translation. To give you a quick idea of what we'll be covering today, we will start by looking at what translation technology is and how do we distinguish between machine translation and computer-aided translation. Then we will explore some of the basic mechanisms behind these technologies and how they differ from human translation in practice. We will also discuss some of the strengths and limitations of them and take a brief look at how they've developed over time and what tools are currently being used in the industry, such as from traditional CAT tools like Trados to newer LLM, large language model-based systems like ChatGPT. And finally, we will touch on how to choose the right tools for different translation tasks. I think the best way to enter the topic, translation technology, is by looking at how society's view has changed on what it means to be a translator over the years. On the screen is a quote by a translation studies scholar, Alistair Moore, back in 2001. So he said, "The image of a long translator is no longer realistic, but the idea of an independently acting, error-free translating machine is equally unrealistic." So from his wordings, especially the "if at all" at the end, we can tell that he probably didn't think the day of that error-free translating machine would ever come. But before we move on to judging whether he was right or not, I think that image, the image of the lonely translator, deserves some discussion as well. On the screen shows the Chinese philosopher Mo Zhongshan. The picture was taken in the 90s during the shooting of a documentary by ATV. The scene happened to be not far from our campus as Mo Zhongshan lived in To Kwa Wan. So Mo was translating the Third Critique, the critique of judgment by the German philosopher Immanuel Kant. This was part of the grand project of translating all three of Kant's critiques, and which took him over a decade in this very little apartment. Imagine, this was one of the most important Chinese philosophers translating one of the most influential Western philosophers. So such a combination is, at least to me, legendary. But nowadays, not only is Mo's way of translating seen as inefficient, but the translation itself has also been widely questioned. So the work was accused of being unfaithful, so to speak, to the original. And there are two main reasons behind this judgment. First, it was not translated from the German original, but from English translations. So if you see the documentary, you will find Mo comparing 3 to 4 English translations as he rendered his own Chinese version. And so he had to do so because he couldn't read German, and the English translations were, as Mo himself had openly criticized, problematic. So perhaps it was simply also inevitable that Mo's translation would also, in a certain sense, doomed to be problematic. And second, perhaps as we could expect from a great philosopher, there were many creative interpretations in the translation. In some chapters, most translators' annotation were even longer than the target text itself. So anyway, in many ways, most work simply did not catch up with modern expectations of translation, and his work would simply be seen as pieces of bad translation today. His way of doing translation is no longer accepted in today's culture. And while this might not be a bad thing not totally a bad thing, uh, from the perspective of the art of translation, I think it's also fair to say that some things certainly lost in it are good translations, really limited to the reproducing of a message. Certainly, there are unique, some unique values in most translation, even it was in many ways not faithful. But since it is not a theory or cultural critique course, we will not go into the details of what makes a good translation. That would be beyond the scope of today's discussion. But one underlying point behind this story that is at least a bit relevant is that our understanding of what translations and translators should be like, and the tools and ways of practicing translation are ever-changing. They are all products of an ever-changing world. So it wasn't only the translation practice, not using electronic devices and surrounding yourself with old books, that is lost. It was also the lonely translator who would produce aged translations with personal character in it that is no longer wanted in the modern world. So what I want you to keep in mind is that being aware of the underlying agenda of the modern culture in the era of information explosion is crucial to understanding the translation technology tools we will mention and we will learn. So if you want to understand these tools thoroughly, you also have to understand what translation culture and modern culture is like at our times. We will elaborate this point further in later slides. But back to Alistair Munro. So it's a day when machine translation performs fully automatically and error-free, really unimaginable. I would say that is in fact already quite imaginable. In fact, I would even argue that its achievement is really just a matter of quality refinement, and it seems to me that the fundamental difficulties have already been overcome. Say, think of the auto transcription and subtitle translation we have on YouTube today. While the speech recognition and auto translations are still far from proficient, it could already work fully automatically and generate intelligible translations. So that's what I meant when I said a matter of quality refinement. And 20 years from writing the quote we saw in the last slide, when Alistair Munro was co-authoring another book on translation technology in 2023, the big picture of not just the translation industry, but the world had already changed a lot. And now, as he would say, we can hardly find anyone who works on a 100% human translation basis in the strictest sense of the term. Wow, there's still a big gap, and it probably won't be achieved in the very near future. I think fully automatic high quality translation, or sometimes we just call it FHQT, is already imaginable. But this is when we need to set some boundaries. So what counts as translation technology? Is checking a dictionary app on your phone counted as one? So on the screen is a very inclusive definition that was made over 20 years ago. It was said that any type of tool that translators use to help them do their job could be counted as CAT. So it could be counted as computer-aided translation. If you have ever watched the movie Three Idiots, in that movie, there was a famous scene at the beginning where the engineering professor asked the protagonist, what is the machine? And our main guy, Rancho, says, a machine is anything that reduces human effort. According to his definition, according to Rand Cho's definition, a machine is anything that reduces human effort. The zip on our trousers is also a kind of machine. Similarly, if we take Bowker's words, then even the already outdated electronic dictionaries could be regarded as some sort of cat tool as well. While that might not entirely make no sense, it doesn't sound too plausible either, right? In fact, as we will see, using outdated electronic dictionaries like the ones on your phone is generally not regarded as computer-aided translation. And also, Bowker's definition could also be challenged from another extreme. Take a look at our latest technology, the interpreter hub shown on the screen, which was introduced in 2024. So the user holds the device to let the mic pick up the speaker's voice, and then the device would generate a translation in the target language with machine-generated voice. So is this a computer-aided translation tool or a translation machine? So if so, can we call the person holding the device a translator? So that is why we need to set some boundaries and more nuanced differentiations. On the screen is a diagram that helps us understand the definition and scope of translation technology and how different types of translation fit along the spectrum. Let's begin with human translation. This refers to the traditional way of translating and what we might call a pure human translation process, so to speak, like Mo Zhongshan. However, human translation is not restricted to the strictest paper and pen mode of translation. Translation modes that use only clerical support tools like electronic dictionaries or even the computer to type on. So these tools do not intersect with the core translating task, and therefore, if only using them, the translation activity would still be considered human translation. Okay, so next, the middle ground. So the middle ground is computer-aided translation. At the lower end of this CAT spectrum, we have machine-aided human translation. So as the label describes, this is basically human activity involving computer-based tools. So the human is the main driver, and the machine is just there for support. And this is what most professional CAT tools are designed for, like Trados and MemoQ. And then as we move further right, we get to human-aided machine translation. So here, the machine is doing most of the work, like in most any machine translation systems. However, a human is still involved to check, correct, or improve the output. So post-editing machine translation would be how we describe this work mode. So the machine does most of the translation work, but there would still be a human editor working on that machine translated text. Okay, so and finally, on the far right, we have fully automatic high quality translation, or sometimes we will just call it FHQ. So this is the hypothetical or ideal scenario where the machine can produce perfect translations without any human input at all. And as we discussed earlier, we are not quite there yet, but that is no longer not imaginable, and we are getting closer to closer. Now, let's take a look at a traditional differentiation between machine translation and computer-aided translation. May I draw your attention that the reference chart was drawn from a 2002 source because I thought this source would be easier for us to clear the concepts. So in the past, when machine translation was still far from being ready to go into actual service, the machine translation category was seen more as a prototypical experiment, something that contributed to the long-term goal of automating the translation process. And like in the chart we see, there was barely any elaboration on the features of machine translation, perhaps because so it was just there almost as a placeholder for future development. On the other hand, all of the technologies that translators actually used in real projects would fall into the CAT realm. Things like terminology management systems, translation memory, and corpus analysis tools. So these were all well developed and actively used in professional translation settings, even back in 2002. So for a long time in history, CAT, computer-aided translation, was the practical side of translation technology, while machine translation was still viewed more as a research ambition or a futuristic goal. But of course, that doesn't mean machine translation never existed in real life. It was quite the contrary, actually. That is the very first machine translation, the very first translation technology hardware, in fact, was a machine translation device, not a CAT device. So what was happening there? So like in the 50s to the 60s, when translation technology was emerging, researchers thought that they could invent machine translators right away, but they only shift to CAT tools only until they found the technology at the time was still far from being mature enough to go for machine translation right away. So they had to work on CAT tools first. So that was the story. Well, anyway, now that we see machine translation refers to technologies where the computer does all the translation work, or at least the primary translation work. So we can look a bit more into the mechanics of how that actually works. And briefly speaking, the development of machine translation has gone through three major stages. And in the more primitive days, machines used what we called rule-based machine translation, or RBMT. RBMT works based on rules and dictionaries written by linguists, so as its name might have already suggested. And you can imagine it like a smart grammar book combined with a bilingual dictionary. The RBMT system tries to analyze a sentence grammatically. It will look at the structure, the word forms, and so on. And then it tries to map that structure into an equivalent one in the target language. So like the one you see on screen is the Yamato machine translation system that was developed in 1959. It was an English-Japanese translation machine, and you see it was a room-sized computer. So it employed an RBMT system, a rule-based machine translation system, rule-based machine translation system. So this was the earliest machine translation system, but it was still dominant until the 90s. So the logic of RBMT is clean and straightforward, but the problem is language is often messy. So RBMT really struggled with things like figurative language, idioms, or just simply longer and more complex sentences. So RBMT was too rigid and couldn't easily adapt to any unexpected input. So like during a demonstration for this Yamato machine in 1959, uh, it translated the English phrase like music as warega or gaku or konobu. So this is technically correct in meaning, and it also managed to transform the English SVO sentence structure into the Japanese SOV1. But it sounds so, but the target test it generated sounded old-fashioned and very unnatural in modern Japanese. So it uses very formal and ancient words. Uh, and they actually rarely the word choices they were rarely used in everyday conversation today. I mean even in those days. So the machine likely used this outdated style because early translation systems focus on direct dictionary word for word substitutions, so rather than natural phrasing. So this example showed one of the most obvious weakness of RBMT, that is the machine could not decide on what is a natural expression. At best, it could only do grammatical sentence rendering and choose and choose a seemingly equivalent word. So then came the second stage of machine translation, SMT, statistical machine translation. This approach, instead of manually defining all the rules, it looks at a huge number of translated sentence pairs and let the computer figure out what's most likely. So it's based on probability. The system learns patterns from large bilingual corpora. Basically, corpora means big databases of big database of translated texts. So this system learns from a large corpora and then uses those patterns to guess the best translation. So it doesn't really understand the meaning, but it's good at learning what kinds of word combinations usually go together. So it became more flexible and more fluent than RBMT, and it could also handle real-world language better. But of course, it still had its limitations, especially with fluency and long distance dependencies in grammar. So there are a few variations among the SMT category. So there's a word-based SMT, which translates one word at a time. So this is a simple model, but often accurate. And there's also a phrase-based SMT, which phrase-based SMT improves by translating short groups of words, that is phrases together. So that would make the translation more natural. And the early Google Translate employs this type of SMT. And also later on, they were also so these are not employed by Google Translate, but after phrase-based SMT, they were also hierarchical phrase-based SMT, so which adds structure by using phrases within phrases and thus handles grammar better. And at last, we also had a syntax-based SMT, which uses grammar trees to decompose the sentence structure. So the grammar trees, for those of you who learned linguistics, might have encountered them as well. So the syntax-based SMT, the logic are similar to that. In short, so all of these SMT models, they use probabilities to choose the best translation, but they differ in how much linguistic structure they take into account. And now we arrive at the third and current stage, neural machine translation, or just NMT. So this is the dominant method today. NMT uses deep neural networks and artificial intelligence technology to process entire sentences at once. It doesn't rely on manually written rules or even count-based statistics, and instead it learns to translate by understanding, so to speak, understanding the sentence as a whole, including its context and meaning. So therefore, such deep learning makes NMT a form of AI. So as it is a type of, machine self-learning. So NMT is much better at producing fluent and natural sounding output. So once again, until today, NMT is still the dominant machine translation system. But we must also note that the quality of NMT outputs rely heavily on how each particular system is trained. So on the screen shows the Mega Honyaku device invented in Japan in 2016. So it is also known as the Voice Translator Megaphone, and it is a portable speech translation device developed by Panasonic. So originally launched for the 2020 Tokyo Olympics. So this voice translator megaphone was designed for use in public spaces like train stations and tourist spots. The device works by capturing spoken Japanese and instantly translating it into multiple target languages, including English, Chinese, or Korean. And then it would broadcast the translation through a built-in speaker. So the name of the device is a blend of the Japanese words megaphone and honyaku, that means translation. So that the name reflects its core function. So even though this device employs an NMT model, so since it was specialized in the public service and customer assistance domain, so particularly for scripted and routine communication in public-facing environments. So it is only reliably good at fixed and formulaic announcements and predefined transactional dialogues. So it could not really handle complex and conversational speeches. So even though this is NMT model, it still could not work like the kind of AI you expect today. So a quick conclusion from RBMT to SMT to NMT. So we have moved from rule-based systems to probability-based systems, and now to deep learning systems. So and each getting closer to how humans actually process language. And now, after the development of machine translation, now let's take a look at CAT, computer-aided translation, which is still the most dominant way of practicing translation technology, at least in the professional sector today. So a quick recap, we can begin by, what's CAT? We may first eliminate some practices from what we would consider as CAT. For example, using spelling or grammar checkers doesn't really count, as you can see on the chart. These kinds of tools still fall under the category of human translation. So because as we have discussed, they don't really assist with the core task of translating meaning between languages. So when we speak of computer-aided translation, we usually refer to we usually refer the narrow sense of it. That is, tools that make use of translation memories, terminology databases, and data capture tools. These are tools that actually assist in the translation process by reusing previous translations, suggesting terms, or analyzing patterns in bilingual texts. In this model, in this CAT model, the human is still doing the actual translation work, but the machine is only there to help make the process faster, more consistent and efficient. And before we get into the practicals of these CAT tools, which might seem very complicated at first sight, I think it might be easier to understand the design logic behind them first. So why were CAT tools created in the first place? Well, in many fields like legal, technical, or software translation, translators often deal with very repetitive content. Say, a washing machine manufacturer that introduces tens of new models each year, but they still had to generate a user manual for each model. So many same phrases, sentence structures, or even entire paragraphs come up again and again across different documents. And CAT tools were built to take advantage of this. The CAT tools store everything a translator works on, sentence by sentence, into a database, which we will call translation memory, TM. So when the next time the translator comes across a sentence that is the same or similar, the tool will suggest that previous translation. So the translator can decide whether to reuse as it is, or edit it slightly, or ignore it altogether. So this setup helps save a lot of time, especially on very large projects. The CAT tool improves not just saving time, but consistency, because you're reusing the same approved translation every time, instead of reinventing or retranslating the familiar sentence each time. And what makes CAT tools different from machine translation is that, most importantly, the human translator is still in full control. So the software is there to assist, but it doesn't replace the translator's judgment or creativity. Now we know how CAT works. We can look into some of the often seen terminologies. First, we have corpus or corpora in plural form. So a corpus is basically a large organized collection of texts. This can be used for language research or to help train machine translation systems. For example, a corpus might contain thousands of translated legal documents or user manuals, so which can help computers learn how the language in that specific domain works, so in the field. Then, next terminology, we have natural language processing, or NLP. So this is a broad area in computer science. It's not a translation exclusive term. So they are fun. So for NLP, well, what's natural language processing? So I think we may explain by telling the fundamental goals of developing NLP. So there are two of them. First, NLP allows us to communicate with computers using natural language. So that is to speak with the computer in English or Chinese or any human languages instead of coding languages. So that is why it got its name, natural language processing. And the second goal of NLP is to build language-based applications that can do smart things like translating, summarizing, or analyzing texts, just like humans do. So that is the NLP technology. Okay, another important concept is segmentation. So this one might be more straightforward. So this is the process of breaking a piece of text into smaller pieces. So usually sentence by sentence or even phrase by phrase. These smaller units can then be translated more easily by a CAT tool or a machine translation engine. It's like cutting up a big job into little manageable tasks. So while it sounds natural and makes a lot of sense, it is in fact controversial as well, because some people who are against machine translation would say that segmentation is where technology kills a text, and segmentation turns the text from an organic piece into dissectable parts. Okay, so the terms in the last slides are still those that are about the underlying logic of CAT tools. And here are some essential ones that you would say and encounter more often as you actually use them. On the screen is a screen capture of the CAT tool Trados. This is the interface for editing and creating a translation memory. The following terms are all translation memory related, and they are things that you have to handle and input before you enter the translation process. So naturally, first we will have TM, translation memory itself. So this is the one of the most important features. So a TM is basically a database of previously translated sentences. So every time you translate a new sentence, it gets saved into this memory. So then if a similar sentence shows up in a future document, the tool will suggest the old translation, so you don't have to start translating it once again. So besides saving from translated documents, TM could also be imported. So you can easily upload, say, an Excel file or a bilingual test of bilingual test and vocab lists, and then the CAT software would help you sort them out into TM file formats. So of course, some point and click work might be required in the process, but it is mostly automatic. So we will see a screenshot of it later in this class. Next, we have something called term-based or TB. This is when you import glossary. So the glossary stores approved translations for specific terms or short phrases. Okay, so there's term-based, and at last for this session we have alignment. So this one is simple. When editing a TM, a translation memory, alignment is the process of matching existing translated text with originals and building translation memories from older projects. So later on, we will also see the more of the alignment document formats. Okay, two more terminologies before we end this session. So these are the ones you will encounter during the translation process. So the first one is fuzzy match. So what does that mean? Well, when we use translation memory, so not every new match is going to be perfect. So a fuzzy match is when the system finds finds a previous translation that is quite close to uh, the current source text. So they are close but not identical. To the sentence you're working on. So, for example, previously you have translated the sentence, take photos of food with more vibrant colors. Okay, so a simple sentence. But now you have encountered another sentence, take photos of food with more vigorous colors. So the sentence is the sentence you are translating now is different from the one in the database. But the CAT tool will still spot it and suggest you the translation of that vibrant sentence. So of course, the software would remind you that the suggestion is not an exact correspondence of the line you're working on, and that is a fuzzy match. So what happens when there's a fuzzy match on the screen shows Word Fuzz Anywhere, one of the most common and accessible cloud-based CAT tools. So fuzzy matches are the translation scored with 88% or 91%. So that score gives you a quick sense of how much editing you would need to do. So you cannot just take the translation memory translation. Okay, and the last terminology, concordance search. So this is a feature that lets you look up how a specific word or phrase was translated in the past. In some ways, it is like the Command plus F or Control plus F function on your computer. But of course, concordance search is much more sophisticated, as concordance search would search through multiple translation memories and would also consider words with morpheme alterations. So that makes it different from just using Command plus F. Okay, so both fuzzy matches and concordance searches, so they are about leveraging your past work. They make sure you're not reworking on the same sentence again and again. So they are how CAT tools are actually used. So the core function of CAT tools when it comes to the actual translating process. Oh, okay. Now that we have gone over the basic building blocks of CAT tools and translation technology, so let's talk a bit about why these tools are so widely used and what makes them so valuable in real-world translation projects. So the most obvious strength of these CAT tools is that they can process massive amounts of text very quickly. Uh, but beyond just speed, they help maintain consistent terminology and phrasing across large documents as well, or not just large documents, so maybe even multiple projects. So this is especially important in industries like law, medicines, or software developing. Also, so while the tools might be expensive itself, so they still have a cost effectiveness advantage. By reusing previous translations and leveraging tools like machine translation and these CAT tool systems, so companies and freelance translators can actually cut down a lot of manual labor. But that, of course, doesn't mean that the translators are no longer needed. It just means that the translators can focus more on, refining, editing, and polishing the target text rather than starting from a blank document every time. So this is especially helpful when working with either tight budgets or short deadlines. So you can get more done in less time and with fewer human input. And also we can maintain the consistency and quality. That is another obvious advantage of these technologies. But also speaking of labor and budget, so there's one thing worth adding as well. So many of these newer platforms, these newer CAT tools platforms, so they are tailor-made for freelance translators. So platforms like SmartCat even has a built-in system to calculate the pay rate for each document. So as you can see in the screenshot, it shows a platform called Phrase, launched in 2012. So I included it here because it really shows how newer CAT platforms are designed with the user experience in mind. So we can see the interface, it's clean, intuitive, and most importantly, it's built for cloud-based collaboration. Okay, so the collaboration feature will be very important. So and that is also what these newer systems stand out from the traditional market leaders like Trados. Okay, so so I guess that's it for the strengths. So now we also have to take a look at the weaknesses. Okay, so these tools are of course by no means perfect. And the first obvious issue is of course the cost. So actually I've just mentioned that already, right? Professional grade CAD tools. Like the industry standard ones like Trados Studio, they can really be very expensive. And this, while it enhances productivity, so for freelancers or students just starting out, this can be a real barrier. And actually, you're not just paying for the software. There can be extra costs for plugins, updates, and even the cloud storage. So these are additional costs to the already expensive system. And while these tools indeed brings cost effectiveness advantage, so you can actually see only established agencies could benefit from it. These tools are very expensive for ordinary freelance translators or even translation students. Some platforms like WordFast Anywhere or SmartCat offer free versions, but they often come with some other limitations. And at the end of the day, the full-featured tools, they are still quite a financial investment. So even you are a professional translator, so you will need to gather some clients' experience and resources to get into these tools. Okay, but other than that, another important issue is the suitability. Sometimes CAT tools are not quite suitable for creative or literary translation because the segment-by-segment approach that CAT uses, they might not fit creative translation. So like as we discussed earlier, CAT tools typically divide your source text into sentences and short statements. So this works great for instruction manuals or product descriptions or things like that. However, if you're translating a poem, novel, or even a marketing copy that requires some creative or specific flow and tone, so the segmentation might become a problem. And also on the screen, I've included a picture from one of my own translation projects. So in this case, I was working on a localization project of an investment app. So I had to translate interactive Mandarin language into Hong Kong Chinese. So here, CAT-tools could offer very limited help. So as there's no TM I can rely on, and also what makes the work a good piece of translation actually has no understanding, has nothing to do with the traditional understanding of similarity rate. So in the end, for projects like this, I will not use a CAT tool and would rather go back to a plain Word document. And now, let me show you another example from my own translation experience. This time to illustrate how real-world translation work often involves much more than just achieving linguistic equivalence. So this one was for a small outdoor cafe. They had the idea of setting up a mini coffee museum in their space, just a few panels introducing coffee knowledge, like how it's harvested, how they are processed, and some fun facts for visitors. Okay, so my job was to translate their exhibition texts from English to Chinese. It was a very interesting project, but as you can probably guess, the original text wasn't written by a professional writer. So it was written by some, a barista. It was more like a casual script drafted by someone with a passion for coffee, but not much training in how to communicate ideas clearly. So take this example here, the paragraph on the flavor wheel, the upper segments. The paragraph on the flavor wheel includes the lines. The key is to taste mindfully, preparing the coffee with care. So what does this sentence actually mean? The key to what? To using the flavor wheel or to brewing better coffee. And what does preparing the coffee have to do with tasting it? So there's a lot of ambiguity here. And as a translator, I had to make a judgment call. So in this case, I decided to slightly alter the meaning in my translation to make it more coherent for the target audience. So of course, not every job gives you this kind of flexibility, but for informal cases like this one, I knew the client would prefer something that makes sense over something that was strictly equivalent. So for these judgments and stuff, this is where CAT tools fall short. Because they segment the text sentence by sentence, so it becomes harder to identify these vague or ambiguous sections as a whole. So if you are focused on the segmentations too much, you end up missing the bigger picture. The bigger picture, like in cases like this, would actually be quite important. And another issue is that when you're working with small business or independent clients, the source text itself might be messy or unpolished. So like in the lower image, you see some red text. So these red texts are mistakes I found in the source text. So they were inconsistent word choices, and there were lots of typos. Sometimes when you work as a translator, you are not just translating. You would also have to do proofreading, editing, or even rewriting for the client as well. But CAT tools aren't really designed for that, so they assume the source text is clean and ready to go. So they do not give you the flexibility to revise the original content. I mean, in terms of the user interface, not even all CAT tools allow you to edit the source text segments. Quick conclusion. So while these CAT tools are great in structured and professional environments, they don't always adapt well to the real world or the kind of freelance works that many of us actually will end up doing. So especially in the earlier periods in our careers. Okay, so at this point, we've already looked at the basic definitions of machine translation and computer-aided translation, and we have walked through some of their key features, how they work, what they're good at, and where they fall short. So now, let's take a moment to summarize what we have learned by looking at the workflow of different translation modes. So on the screen, you'll see the first two flowcharts, one for human translation and the other for machine translation. First, for human translation. So this is the most traditional and intuitive form of translation. So the process is quite straightforward. The entire responsibility lies with the human translator, and every decision from word choice to sentence structure to tone and registers and so on. So they are all made by the person, the translator. So there's no automation involved in the core translation work, and that's human translation, you know. Okay, and a quick recap. So even they use basic digital tools like spell check or dictionary app, we still consider this as human translation. So because the technology doesn't interfere in the translation process itself. All right, so now compare that to machine translation. So instead of the human doing the translation from the very beginning, a machine translation engine like Google Translate first generates a draft translation, and then a human translator will step in to post-edit the output. So this post-editing step might involve correcting grammar, refining word choices, or even restructuring entire sentences. So sometimes the machine's output is usable with light edits, but other times it might be so off the mark that the human has to practically retranslate the whole thing. So the key difference here is who, so to speak, does the work, does the hard work. So in human translation, the human leads the entire process, but in MT, the machine takes the first shot and the human just follow up with corrections. Okay, before we move on to the workflow of CAT tools, I want to take a moment to return to machine translation. So, and specifically, the question of FHQT, fully automatic high quality translation. So, as you mentioned earlier, machine translation refers to a process where the machine generates the initial translation and the human steps in as a post-editor. So in theory, the ultimate goal is to reach a point where the machine can handle the entire process by itself, that is producing translation that are as good as or even better than humans. So of course, without human intervention. So this goal is what we refer to as FAHQT. So now, for a long time, this idea felt more like a science fiction, even in the days of neural machine translation, that is 2016. The result still weren't great. The output was still quite clumsy and unnatural or incorrect, that most translators would rather start from scratch than to fix the machine translation. But in recent years, things have changed. The output of systems like the Google NMT and LLM generative AI models have improved to the point where machine translation plus post-editing workflows have become genuinely usable for certain types of content. Naturally, a lot of attention has been placed on how much editing is still needed. So everyone wants to know how close are we to FHQT? How much human labor can MT actually save us? But what's often overlooked is that, so just like CAT tools, once MT becomes a real part of practice, it actually also brings with a whole set of new tasks. So a task that happened before the machine translation even begins. Okay, so let me show you an example from my own experience. On the screen shows a translation job I did for an academic research group working on an oral history project. So my task was to translate Cantonese interviews into English. Now, it might sound like a perfect case for machine translation. The source tests were casual conversation with simple language and straightforward sentence structure. But what I received at the beginning of my job was just a set of voice recordings and a raw, terribly AI-generated transcript. So you see in the generated transcript, the sentences were broken, the formatting was inconsistent, and in colloquial Cantonese, people often speak in fragments or overlapping turns, so which are completely understandable to a human listener, but unintelligible to a machine translation system or a text reader. So what did I have to do? I had to manually clean up the transcript, restructure the sentences, and correct speaker labels, and even input proper names to the MT systems so they wouldn't mistranslate or mess up with the terminologies. And honestly, by the time I finished all of that, I had already spent almost as much time as I would have if as much time as I would have if I had just translated it by the human translation mode. Okay, so the takeaway of this story is that first, machine translation isn't always as automatic as it seems. There's often a pre-translation stage, or what I think that is not a conventional academic name for it yet, but I would call it pre-editing. That's essential for for making the source test usable by the MT system. And another takeaway is that if we really want to achieve FHQT in a practical sense, from this story we learned that we need more than just better translation engines. We also need better tools for handling the entire workflow, like things like transcription, OCR, formatting tools, and automatic document cleanup. So without these supporting tools, the translation itself can't even begin, right? So once again, so we are reminded that translation technology isn't just about the translation, it's about the entire pipeline. And that's something we will see again when we look at CAT tools next. Okay, now we've looked at the workflows of HT, human translation, and MT, machine translation. So let's complete the picture by adding the last two modes. First, computer-aided translation, CAT. So in this model, we still begin with the source text, but the translation is handled by human and the translation is also handled by a human translator, just with the assistance of CAT tools. Unlike machine translation, the core work is still done by the human. The translator is the one in charge of deciding how the meaning is carried. Actually, we have repeated that many times. So what makes CAT tools a computer-aided tool is that it only provides support. So they may suggest translation from translation memories, They might highlight term from a term base and offer fuzzy matches and all, but they are only here to assist. So I think that concludes the CAT workflow. All right, and finally, the hybrid workflow. So this model blends both MT and CAT, and is becoming actually more and more common in the industry today. Here, the process begins with a machine translation system generating the initial draft, and then, instead of just a human post editor, we now have a post editor working within a CAT environment. So that means the editor not only revises the MT output themselves, but it also benefits from usual CAT tool features, TMs, TBs, and other productivity aids. So this is a layered workflow. So the machine does the first draft, and the CAT tool helps manage and structure the work, and the human editor does the quality assurance. So as you can see, each of these workflows, HTMT, CAT, and hybrid, offers a different balance between human control and machine assistance. And by now, we have covered quite a bit of ground on how these technologies work. So when they're useful and what limitations they might have. So to bring all of this together and give you a chance to reflect on this knowledge, so let's move into a short discussion. So here's the scenario. You have been hired by a global tech company to translate a set of internal confidential documents. The materials are highly structured, written in a formal tone, and follow strict style guidelines across different departments. You're expected to deliver the translations on a tight schedule and collaborate with other linguists working on different sections of the materials. All right, so now the question is, which type of translation technology would be most suitable for this task and why? Okay, so you may take a minute or two to think about this. You can discuss with the person next to you or just reflect on your own. Think about what we have talked about so far, the nature of the test, the workflows. So these are all things to be considered. And after a few minutes, I will share my own perspective on the question. Okay, let me share how I would approach this situation. So given the nature of the task, structured content, strict style guidelines, etc., so I would say that computer-aided translation tools would be the most suitable technology. First, CAT tools works especially well with highly structured tests. So because of the consistent format, you may benefit a lot from the translation memory and fuzzy matching features. And also the collaborative aspect. So many modern CAT tools allow cloud-based collaboration. So multiple translators can work on different parts of the same project at the same time. So while sharing the same, TMs and TBs. But you may also be thinking, so why not using machine translation? So as part of the hybrid workflow. But since the documents are confidential and MT system often rely on cloud servers, so that might raise security concerns. So unless the company has its own secure in-house machine translation engine, so it will be unless they really have such an engine, it would be more appropriate to employ a CAT-only workflow for this case. Okay, so overall, CAT tools, strike the right balance between human control and the speed and automation of machine translation. So that's why I would think CAD tools is the best fit for this kind of task. Okay, the hybrid workflow might still, I know, might sound a little confusing in theory. So let me walk you through one of my own experiences that really illustrates how it can play out in practice. And of course, there would also be some problems in it, as translation is always full of, problem solving. So this was a project involving the English translation of a Chinese academic book published by a well-known academic press. The publisher had partnered with a university-affiliated organization to manage the translation process. So the coordination was handled by that university group, which then outsourced the translation to a group of freelance translators, and I happened to be one of them. Each translator was responsible to translate 1 to 2 of the chapters. So here's how the process went. First, to cut costs, the publisher decided to machine translate the entire book using a pretty outdated AI model. So the raw machine translation output was, frankly, a mess. So as you can see on the screen, both in terms of language quality and formatting, and you can and so what you saw what you see on the screen is actually what we translator received. Okay, then this machine translated draft. They were sent. These drafts were sent to a team of freelance translators. They were only paid on proofreading rates, less than half of a normal translation fee. Their task was to post-edit the machine translation and make it publishable. So now this setup technically fits the definition of a hybrid workflow. So the MT does the first pass, humans come in to fix it. And in theory, everyone saves time and money. Okay, but here's where things fell apart. So first, there was no centralized CAT tool, no shared translation memory, and no unified terminology. Were made before all these task distributions. So one is likely that each translator used their own personal CAT tool. They were working in isolation. And so even though they were all editing the same book, there was no consistency across chapters, no way to check terminology, and no infrastructure for collaboration. And as one might expect, the result could hardly be satisfactory. So the editing team at the publisher's end, or the coordinating from the university side. I wasn't, as a freelancer, I wasn't very sure how the admins worked. So anyway, whichever side would have to spend enormous amounts of time fixing inconsistencies and correcting and unifying the terminologies, as well as resolving those formatting issues. And ironically, so if they had just paid proper translation fees or invested a bit of time upfront to prepare a term-based or a shared TM, the entire process would have been faster, cheaper, and much higher in quality. So it's very similar to the oral history case study I shared earlier. So once again, it becomes clear that translation is not just about the words. There are a lot of moving parts, technically, linguistically, and from the organizational sense. So that all need to work together. From a perspective, this project was a failed experiment in hybrid workflows. Some might even call it a form of labor exploitation, considering the rates and the expectations placed on the freelancers. But for me, I would think this was worth attempting. So I mean, the experiment was at least worth a try, and that's why I became part of it. Because it shows us in very concrete terms, so how things would go when translation technology is used without proper planning, and such experience might serve as a reference for future improvements. But to conclude this case study, so this case study is just a reminder that tools can't replace workflows, and then cutting corners in one part of the process usually would just create problems in another. So, as we saw in that last case study, the challenges weren't just technical, they were also structural and professional. So, and in many ways, it reflects the fact that the translation industry itself is transforming as well. This, of course, isn't just about new tools or new workflows. It's about a shift in what translation means as a profession, and what kind of expertise the industry is beginning to value. So as we saw in that last case, that the challenges weren't just technical, they were also, they were also involved, an overall mindset or understanding of how the industry should run. So what role should each side or each party, what responsibilities should each party share. So these are all changing along with the technology advancements. Okay, so but anyway, so here's an article I came across with a few months ago. So the article touches on this topic. So it argues that the relationship between machine translation and human expertise, if we understand it correctly, shouldn't be a zero-sum game. It's not that one replaces the other. Instead, what we are seeing is that translation or translators are no longer, a standalone professional service or professional service providers. It's becoming part of a much broader and integrated language service industry. So they do not just do translation works anymore, but they also deeply connect to fields like tech, operations, and AI, and all these kinds of stuff. So in other words, translation is evolving into language solutions. So where a linguistic expertise is, applied across platforms and softwares, and they would also, translators would also need to know about tech, localization, corporate communications, content strategy, and so on. And with the rise of AI, the article suggests that we will likely see entirely new translation-related roles emerge, roles that don't even, roles that never existed before, and these roles would require a mix of language skills and tech literacy and operational know-how, and yes, and that really and that beyond that, it also raises a really important question. So as we continue to train translators in traditional language pairs like Chinese to English translation, Chinese to English translation courses, so you still offer a lot of these trainings. So but at the same time, can we also begin to prepare for other new specializations, and let a new industry comers learn about these new workflows and new ways of working that align better with the global development. Okay, and even more ambitiously, uh, can we imagine building a cross-regional, time zone spanning Chinese language service network? So where professionals collaborate across borders, bringing together linguistic and technical expertise or even cultural expertise. Okay, now, of course, whenever we talk about AI or machine translation, there's always a concern that these tools will replace translators. But I think the same way as the author here, so that such a thought is based on misunderstanding of what translation really is. So here it comes to the later half of the paragraph I pasted on the PowerPoint slides. Okay, the truth is, translation has never been purely a linguistic activity. So it's always been something that adapts to the needs of the world around it. Translation is a way of moving between systems, communities, and cultures. And that's what the quote in the article really meant. So without translation, there would be no Christianity. So a translation has always been a force for connection and transformation. And in today's hyper-connected, information exploding, fast-moving world, that role is more important than ever. And the article argues that, which of course I would agree, that machine translation didn't appear out of nowhere. It's simply a response to the growing demand for translation, a demand that far outpaces what human translators alone can supply. So instead of replacing us, machine translation is highlighting just how essential language professionals still are, not just as translators, but as editors, curators, or collaborators. So again, here I actually share the author's opinion. So after the initial shake-up when these machine translation technologies are introduced, what we will see is not the death of the translation industry, but a rebirth, one where human expertise becomes even more valuable, precisely because of the presence of these new technologies. But now, let's take a step back and look at how we end up getting to where we are today. Let's start at the very beginning with the birth of machine translation as an idea. So in 1946, one of the first general-purpose electronic computers was invented, and it marked a turning point uh, in how people began to imagine the possibilities of automation. So naturally, including language. So of course, computers weren't built for language processing. At first, they were designed to calculate artillery trajectories, but its existence showed that machines could process large amounts of data automatically. So that sparked the imagination of the linguists. So people start to matter. So people they start to think, if computer can solve complex math problems, so why not we also use them to translate words? So a few years later, in 1949, Warren Weaver wrote a now famous memorandum that is laid the foundation for machine translation. So the memorandum was in fact just some casual letters to his friends, and was no research paper, but it did brought some impact, so it was remembered. And in those letters, he proposed that languages share some kind of universal structure. So as you could see at the beginning quote of the slide, we might be able. So he thought we might be able to build machines that could translate from one language to any other because they share a universal structure. So to put it realistically, he imagined using rule-based processing or statistical, which both would become the backbone of early machine translation systems. So yeah, so from this quote, we can see that one of the motivations of inventing translation machines was actually to decode Russian coded messages. So once again, we see translation and technology was, this is not a ivory tower discipline, but its development always had to do with what was happening in the world. So anyway, fast forward to 1954, we got the first real public demonstration of machine translation. So much like those, those sort of Apple showcase of the new products. So it was the Georgetown IBM experiment, where a program translated over 60 Russian sentences into English using simple rule-based system. But of course, it was a highly controlled uh, 60 Russian sentences, so not just any sentences. They intentionally chose that simple sentences that the machine could handle. Okay, and then those 60 sentences were input to the computer by punch cards, like you can see on the screen. But anyway, of course, it was very primitive, but it still managed to impress the public and, more importantly, policymakers. So, that earned them, that earned the research team a huge grant to carry on the development of those translating machines. So, at first, there was a widespread belief that a fully automatic high quality translation, FHQT, might be just a few years away. But by 1966, the optimism ran into reality. So the famous LPAD report. So this one is real famous. The LPAD stands for Automatic Language Processing Advisory Committee. So they delivered a report which concluded that machine translation had failed to meet expectations, and that the system developed so far were expensive, slow, and inaccurate. As a result, the funding for machine translation research was drastically cut, and after that, the field shifted focus. So rather than aiming for fully automatic systems, so now they began to explore on how computers could assist human translators instead. So this all happened after the 1966 incident. So therefore, 1967 marked the period of a new period for CAD development. Okay, so here on the screen you can see a screenshot of modern CAD tools. So the screenshot is not during the 1967 to the 1983. It's just an aid for you to see how CAD tools look today. So why I included this picture? So I wanted to tell you that during 1967 to 1983, the development of CAD tools was still very much foundational phase. So there was actually no mainstream commercial CAD systems. Most of those innovations were just happened within academic institutions and research labs. They weren't built for everyday usage. Therefore, you see on the screen shows the dual window interface. So actually, this interface wasn't invented until the 1980s. So you can imagine just how fragmented and hard to use those systems were before 1980. So actually, they were more like command line experiments than real productivity tools. So Yeah, because of that, very few translators actually use them in real workflows. So this is a period of trial and error, and CAT tools were still academic prototypes. But as we move into the late 1980s and the early 90s, we start to see the transition from academic experimentation to commercial application. By this point, the idea of translation memory, which had taken shape of translation, CAT tools. The TM was finally invented between the late 1970s to the early 80s. So according to translation historian John Hutchins, the first person to propose the concept, at least formally propose the concept of translation memory, was Peter Arthon. If I remember right, he worked with the European Commission. So too bad that for such an important figure couldn't look for his pictures, so I only included a cover page of one of his articles here. But anyway, his proposal of the translation memory marked the beginning of CAT2 commercialization. So key events include the establishment of Trados in 1984, and in 1988, IBM Japan released the eTalk Dictionary, a bilingual electronic resource that supported translation processes. And in 1991, Stygee released Transit, one of the first commercial CAT tools to feature a working translation memory. And in 1992, Trados launched its first commercial CAT system. And then it expanded quickly to markets in Germany, Russia, and the United Kingdoms. As we move into the 1990s and early 2000s, we start to see a real boom in the the development and perhaps more importantly, the availability of CAT tools. In between 1993 and 2003, the number of these systems exploded. So around 20 new systems were developed and released for commercial use in this period, which means a six-fold increase in just one decade. So clearly, this was a period of steady and significant growth in the CAT2 industry. And what drove this growth includes first, developers started adding new built-in functions. So CAT tools weren't just about storing translations anymore, but they also began to include features like alignment, machine translation integration, that is some early statistical empty systems or some built-in empty system were available in some of these early CAT tools. And in this period also emerged project management tools, which helped translation agencies or teams to organize files and assign tasks and track progresses and so on. Okay, and another big factor was the rise of Windows as the dominant operating system. As Windows became the standard in offices around the world, so the CAT tools evolved to match, and this meant they could support a much wider range of file types. So by the early 2000s, CAT tools could handle not only Word documents, but also HTML, Excel, or even PDFs in 2003. So CAT tools had gone from being at the very beginning, academic prototypes to niche tech products to now in the early 2000s. You know, they have already become products used by a handful of translators and companies. So and they began to be used all around the world. And between 2004 and 2013, CAD tools really started to mature and take off globally. So one of the key differences in this period is a major shift toward cloud-based and web-based systems, which allow translators to work from anywhere and collaborate in real time. And another worth mentioning change was the unification of file formats. So before this, every CAD system had their own file types. But now, I mean, during this period, we began to see open standards like Swift, TMX, or TPX, which make it easier to share files across different platforms. So these file types, they are still used on this very day. And then from 2014 and 16, so a short period, but we entered a major turning point in translation technology. That is the rise of neural machine translation, or NMT. As Cohen would describe it, this modern restoration of neural methods in machine translation started with the integration of neural language models into traditional statistical systems. So at first, neural networks weren't replacing old methods. They were just meant to enhancing them. However, that actually changed quite quickly. So by 2015, researchers introduced fully neural systems. That is neural systems built on what we call sequence-to-sequence models with attention mechanisms. These models could better handle context, grammar, and even word choice by processing whole sentences rather than just word by words and phrases. And that same year, a fully neural machine translation system competed in the Workshop on Machine Translation, the WMT, one of the top global evaluation events. And surprisingly, perhaps not surprisingly, it performed as well as traditional systems, or even better than traditional systems. So therefore, that marked a huge moment. It showed that neural networks weren't just theoretical, but they were already ready for real-world use. So during this short but important period, there's a transition from the statistical machine translation to neural machine translation. And that's also set the stage for the translation tools and AI-driven systems we use today. And from 2016 onward, we entered the era of NLP dominance. So in November 2016, Google Translate made headlines in the industry when it switched from statistical machine translation to neural machine translation. It began just with the language pair English and French, and the results were immediately noticeable. So because the translations really sounded much more natural and fluent. But what really made this shift revolutionary was something that popped up later on, called zero-shot translation. So as the system improved, it learned to translate between language pairs which hadn't explicitly been seen being trained. So that is what we call zero-shot learning. As the scholars will explain, zero-shot learning consists in recognizing new categories without training examples. That is by providing high-level description that relate them to categories the machine already knows. So to put it in simpler terms, the zero-shot learning system doesn't really need direct examples. It can generalize and figure translation out based on what is already learned. And so from 2016 onward, NMT completely reshaped the landscape of machine translation research and development. So to borrow Cohen's words again, within a year or two, the entire research field of machine translation went neural. Okay, and now we are in the era of also besides NMT, also LLM, large language models. They've also brought a whole new level of capability to translation. So unlike traditional CAT tools or even NMT systems, LLMs like GPT can do much more than just translate. So these models are trained on massive amounts of data, so they're able to understand broader context, not just sentence by sentence, across entire documents. So so some of the useful features would include you can actually tell the model to use a specific tone, style, or format. Say you may customize it for generating formal tone or casual voice outputs, and you may even convert and expand bullet points into paragraphs. Okay, just give a prompt and the system will adjust the output accordingly. And LLMs can do multiple translation-related tasks at once. So, for example, they can translate plus summarize and even localize the content just within one single step, one single prompt. Oh, so that would be a huge time saver for translators and localization teams. So like here on the screen, using a GPT translate Chinese to academic English chatbot. This is the bot I used to work on the interview scripts in the oral history project I mentioned earlier on. So I first input a large log of conversation, and then it generates an English translation. But that is, of course, not the end of the story. So after the translation, the bot would go through a self-evaluation and see if there were any inconsistent word choices or hard to understand cultural reference translations. And then it would generate a reinterpreted translation, and it will also detect redundant content and cut short some of the repetitive parts. So from this example, we can see with LLMs, we are no longer just automating translation, but we are also, integrating some of the editing works with translation work and combining them into one single prompt. And now we have to enter the unavoidable difficult topic. So that is what all this means for human translators. So you see today, many genuine translation tasks, so especially those repetitive ones, can be primarily handled by machine translation. So this has only, the LLM advancements has and NMT advancement has only intensified a narrative that has been around for years. That is, AI is going to replace translators. Okay, so and just a few days ago, I came across a social media post based on a viral survey titled "Top 40 High-Risk Jobs That Might Be Replaced by AI." And perhaps with no surprise, translators were right at the top of the list. And we have all seen similar headlines before. Of course, this isn't anything new. The fear that machine translation would make human translator disappear has been with us ever since the public launch of Google Translate in 2006. So now, I don't want to just stand here and sourly refute the claim that AI will replace humans. Instead, I want to ask another question. Why is it that translation is always one of the first professions people assume will disappear? I believe there's a historical reason for this. As you just saw in the history session, translation technology was one of the earliest ideas in the practice of artificial intelligence. Even as far back as the 1950s, researchers were already imagining a future where computers could translate between languages. And in fact, if you visit the Wikipedia page on AI winter, the term for periods when AI research lost funding and public interest, you will find that the very first AI winter in 1966 was triggered by that LPAC report, which concluded that machine translation has failed to deliver. So in a way, the development of translation technology has always been used as a barometer for AI progress. And before anyone even heard of large language models of generative AI, people were already saying Google Translate is going to replace human translators. But here's what's fascinating. So given the ever exponentially growing development, having decades of start didn't make AI translation technology outpace other areas of AI significantly. So today, we see people with no programming background building successful and award-winning mobile apps using AI-assisted no-code platforms. But when it comes to translation, I mean real high-quality translation, so we still don't see anyone without bilingual and translation knowledge producing genuinely good translation work. So here we surely would exclude simple translation, the kind that could have been handled by CAT tools long before AI. Okay, so anyway, but for anything beyond that, it seems to me that language expertise still really matters. But that said, AI has absolutely reshaped the status of translators. So in the past, being multilingual, I mean by past, centuries ago, being multilingual was a rare and prestigious skill. Translators were seen almost as language wizards, and they were gatekeepers of knowledge and between cultures. But today, multilingualism is far more common, and basic language conversation can be handled by machines. So it's no surprise that the prestige once associated with the profession has faded. But again, this is of course not unique to translation. And in fact, this is the reality across all knowledge industries in the digital age. So thanks to the internet and now AI, actually no skill or body of knowledge is as exclusive as it once was. We have been heading in this direction for decades already, and translation is, just one of the many professions being reshaped, but not erased. So yes, the prestige and exclusivity of being a translator may no longer be what it once was. Like in the past, we might see a court interpreter as some top tier language users. Uh, but that doesn't mean even it's no longer so. That doesn't mean translators are becoming irrelevant. Rather, we should say their role is evolving, and in many cases, it's becoming even more specialized and critical, especially in high-stake contexts. So here's a recent article I came across, published just a few months ago. So it was a Medium article, but written by a conference interpreting studies professor at NTU. The article discusses the results of a large-scale evaluation on AI interpreting performance in formal conference settings. One of the key findings was that AI interpreting is still not suitable for use in formal high-level contexts like diplomatic summits or multi-language policy meetings. For example, in tests involving Chinese as a target language, the average score was only around 40%, and as a source language, just slightly about 45%. So the AI-generated interpretations were often grammatically correct and fluent, but just on the surface. When used in context like in the United Nations style speech, the output in fact lacked the rhetoric control, tonal accuracy, and clarity that makes the interpretation actually understandable. So even so in this United Nations style speech, even small pauses, hesitations, or misalignments in rhythm can make a huge difference. So in this kind of formal speech context. So and these are precisely the things that human interpreters are trained to handle. But it seems that current AI systems are still struggling with that. So the WHO also released a report recently that pointed to similar issues. So while AI has made huge advances in speech recognition, it still struggles with understanding and rendering meaning accurately, especially in complex domains like law, medicine, or diplomatic discourse. So as I've said before, technical improvements can be expected. But what's even more concerning and fundamental is that errors made by AI often sound fluent and convincing, which makes them harder to detect and actually potentially more dangerous. As Professor Fan notes in the article, the danger is not that the machine gets it wrong, it is that no one notices. So again, it's not that AI won't play a role in translation. Of course it would, and it does. But when it comes to high risk and high impact communication, there's still no substitute for expert human judgment. So actually, it's a bit like the ongoing debate in legal circles. I don't know if you've heard of that. Some argue that AI could make better judges than human because of their superior analytical abilities and consistency. But the real issue isn't just about who can process information better. It's about who takes responsibility for the interpretation and who bears the ethical weight of the decision. So I think it's the same way in both, judges, legal judges and translators. So in translation, especially in sensitive or formal context, it's not just about the, so to speak, language processing, but it's also about, the judgment, the accountability, and the human presence. So this is where the role of translators is shifting. So they are no longer language converters, but as quality controllers, risk managers, and so on. So they are the essential role and responsibility they bear could not be transferred that easily. All right, so now let's shift to another topic, a more practical one. That is, we will look at some of the most commonly used tools in the translation field today. But just a quick note before we dive in, I want you to keep in mind that conceptually speaking, generative AI translation tools are also a form of machine translation. But in the following slides, machine translation, MT, refers to neural machine translation tools like Google Translate and DeepL, while AI tools refer to LLM models and tools like ChatGPT. We would like to differentiate them because they are applied very differently in actual practice. So even though they are all machine translation tools. All right, so let's start with machine translation tools, specifically neural machine translation or NMT. So some of the most common examples you've probably used or heard include Google Translate, of course, Baidu, and DeepL. So these tools are useful when you need to quickly understand content in a foreign language, like skim reading an article, checking out a menu abroad, or casually browsing international websites. However, machine translation tools shouldn't be used for professional translation tasks unless there's human post-editing involved. So as you can see from the examples on the slide, the same input can produce quite different results depending on the platform. And now let's do a quick class activity. So on the screen, you will see a short English paragraph and two Chinese translations, one of them from Google Translate and the other from DeepL. Please take a moment to read both translations and then compare them. And your task is to evaluate which translation you think is more effective. And of course, try to explain why based on accuracy, tone, fluency, or anything else you notice. And we will go into discussion a few minutes later. All right, for this class activities, I chose 3 points for the discussion. So there are only some of the points that make the two versions different. They, of course, do not exhaust the analysis. But first, look at the red words. So Google uses 應對這個變革時代，while DeepL says 邁向這個轉型時代。應對 suggests reacting to a challenge, which feels a bit tense, but 邁向 feels more neutral and aligned with the idea of navigating change. Also, 轉型時代 sounds more natural than 變革時代in Chinese, so it's commonly used in formal writing. And second, let's take a look at the blue words. Google uses 問責 and DeepL uses 責任. 問責 sounds like something being held accountable, like government officials, but 責任 is broader. It simply means having responsibility, which fits the tone of the source better. So it's also more common in Chinese policy or ethical discussions. And finally, the purple words, the Google Translate uses 指導, while DeepL uses 導向. 指導 is very top down. It sounds like giving instructions, but 導向 adds a sense of respect and guidance based on values. So it softens the tone and fits better with the idea of innovation being guided, but not controlled. So overall, DeepL's translations sound smoother and more domesticated, closer to how a human might naturally write in Chinese. And in fact, its power of domestication and rendering natural expressions has been one of DeepL's selling points. Now, let's take a look at generative AI tools, which are powered by LLMs, large language models. So some common examples include ChatGPT, especially GPT-4, great for drafting, paraphrasing, editing, or checking tone and textual analysis, and so on. And also DeepSeek, which is more focused on language, Chinese language tasks, and also Cloud3, known for strong reasoning and context retention. So these tools are useful for supporting tasks like drafting the first versions and sometimes brainstorming alternative word choices. So they can even carry out translation plus those supporting tasks within one single prompt, as I've briefly mentioned earlier on. And here's an example of how generative AI tools like ChatGPT can support translation tasks. So one really helpful feature is the ability to regenerate multiple outputs. This means you can instantly get alternative wordings and compare different phrasings and choose which one fits your purpose best. And you may wonder, so why ChatGPT can give different translations each time, but tools like Google Translate give only one? The reason is that LLMs are designed to generate language with flexibility and most importantly, contextual awareness. So LLMs predict the next word based on probabilities across a wide range of possible continuations, which allows for multiple plausible outputs given the same input. In contrast, neural machine translation tools followed a fixed algorithm, so always producing the most statistically likely translation for a given input. So with LLMs, you get more creativity and choices, but also because of that, the responsibility to the users to evaluate the options carefully. So will also become a thing. And now, finally, let's take a look at CAT tools or computer aided translation tools. So the most common examples include Trados Studio, which is popular in the industry and has a very professional interface. There's also MemoQ, an established brand known for being more user-friendly and work fast anywhere, cloud-based and easy to access, like any other newer platforms. So including Phrase or SmartCat, etc. CAT tools are especially helpful when you're working with technical or repetitive content, or when your project involves or offers translation memory and term bases. So they are especially good for team projects and agency workflows. So now let's walk through a realistic scenario where CAT 2 can be helpful. So imagine it's New Year's Eve 2024, and you're the translator for the for the transport department. You're responsible for translating the public announcements about the traffic arrangements on New Year's Eve. So as you can see on the screen, the announcement from 2023 is quite detailed and the content is very similar. The celebrations are more or less the same every year. So also there's an expectation to keep the wording and phrasing consistent across years. So they want every year's announcement to look similar. So this is exactly when a CAT tool becomes useful. So it reuses previous translations from the translation memory, and then they would automatically suggest similar sentence patterns, translation for similar sentence structures. So like for this scenario, let us use Trados Studio 2024. So what we have to do is, first, we have to manage our translation memories by alignment. So alignment is the process of taking existing bilingual documents, like for this case, last year's Chinese and English announcements, and telling the software which parts match. So the screen capture you see on screen is a pre-aligned version where the system could not detect very accurately which sentence corresponds to which. And once aligned, that data gets saved in your TM, and from then on, anytime you translate similar content, so Trados can automatically suggest previously used translations. And after importing the translation memory, so now we can work on the current document. So on the screen is the 2024 Chinese announcement, which you have to translate it into English. And so now we have imported the source text into Trados. And let's take a look at the first segment, so which is the title. This is exactly the same as last year's. So when you click into the target text segment, the system would actually automatically detect an exact match in your translation memory, and the previous translation would appear instantly in the target field. So you see the translation typed on the screen. I didn't type it. It popped out automatically. And for segment 2, just like the first, Trados detects a similar match in the TM and automatically suggests a suggestion. But this time there would be some inconsistencies, so which we would call it a fuzzy match. Last year's New Year's Eve announcement was made on December 29th, but this year, as shown in the source text, it was announced on December 27th. So Trados can tell that a similar sentence was translated before and presents it to you, but it does not edit the details for you. The translator is the one who still has to read and translate carefully and make all the decisions. So you see, even it could detect that in this source text, the date is different from the past. The popped out suggestion it is still only presented the saved translation memory. So this shows the core difference between CAT tools and machine translation. Once again, CAT tools only support translator, but they can't do the primary work for human, and that's why they got their name, computer-aided translation. Okay, so that's how a CAT tool basically works. The interface may seem complicated, and you may not find the right button the first time you use them. But actually, the underlying logic is quite simple. So once you get used to it, it becomes much more intuitive. And since it's almost time, so before I end today's class, I would like to assign you some post-class reflection questions. So these are, of course, open-ended, so there are no right or wrong answers. The goal is just to help you reflect on what we have discussed and how it might apply to your future work. So here are the questions. First, how would you respond to the common claim that machine translation and AI will eventually replace human translators? Consider how the role of human translators is evolving and reflect on the ongoing need for creativity, cultural sensitivity, and cultural thinking in translation. And second, what skills should future translators develop to remain competitive and relevant in an AI-assisted translation landscape? Think beyond language proficiency. Consider what technological or domain-specific skills will help translators thrive in the industry. So please take a few minutes after class or later today to write down or take some notes on your thoughts. Of course, you do not have to submit them, but you can discuss them anytime in future sessions. So here are the details of the articles and books I used for this class. So, all right, I think that's it for today. Thank you very much for your attention, and I look forward to seeing you again.